In this video, we are going to take a look at reflecting across a line of reflection. So let's just make sense of this image over here, and then we will make sense of it in words. So I notice we have triangle ABC. And then I see the same triangle over here. Do you see this notation A with that little mark after it, whatever we call that? It's called a prime, so this is A prime. So you have point A and A prime, you have point B and point B prime, point C and point C prime. This line M right here is our line of reflection. You can see triangle ABC, the pre-image got reflected across our line of reflection and resulted in triangle A prime, B prime, C prime. Okay, so a reflection has these properties. If point A is on line M, so if your point is on the line of reflection, then the point and its image are the same point. So A is the point, A prime is the image. They are the same point because if you're on the line of reflection, you're not off of it to reflect across it. You just have the same point in the new image. If point B is not on line M, so we can see point B over here is not on line M. Line M is the perpendicular bisector of segment B, B prime. So here's point B, here's point B prime. The line of reflection is a perpendicular bisector. So we can see that if I connect B to B prime, that's that segment B, B prime, it's going to be perpendicular to our line of reflection, and because it's also a bisector, it is cutting B, B prime in half. So from B prime to the line of reflection, that will be the same as from B to the line of reflection. The reflection of triangle ABC across line M can be written as so we're getting into some notation here for reflections. This capital R stands for reflections. Whatever we put in a subscript down here, that's the line that we're reflecting it across. So the reflection across line M of triangle ABC is equal to triangle A prime, B prime, C prime. A reflection is a rigid motion, so that means that the length and angle measures are preserved. Okay, so we're going to work on reflecting something ourselves. In example 2, reflect across a line of reflection. So how can we reflect triangle FGH across line L? So if we just reference real quick our reflected images up here, we can see we have from each vertex of our figure that is not on our line of reflection, we've got this dashed line, and this dashed line is perpendicular to our reflected line. So that's going to be the first thing we're going to do. We are going to draw in those perpendicular lines as best we can. So without, exact measuring tools, we're just going to find ways to make that happen. So I have this rectangle right here. I'm going to use this to help me get perpendicular lines. My rectangle has right angles, so what I'm doing is I'm going to line up the corner of my rectangle with my line of reflection, and then with a vertex of the triangle. So that's pretty decently lined up. Now I'm going to go ahead and draw in that dashed line just along that right there. So what that gives me is the start of a line that is perpendicular to my line of reflection. Then I'm just going to take my rectangle, I'm going to line it up with that line I just drew, and I'm just going to extend that line. Oh, maybe I have to turn my rectangle a little bit. All right, and I'm going to just continue to draw along the edge of that rectangle. And there's my first perpendicular line to the, that line is perpendicular starting with vertex H. So I'm going to do that with each of the vertices. I'm going to line up my rectangle with the line of reflection. I'm going to draw in just along the edge of it. So you could do this with a folded piece of paper. Maybe you have something rectangular shaped. You know, we're just kind of doing our best here to make do. I'm going to continue that line. And then I've got this last one to do. I'm going to bring it over here, line up along the reflected line with my vertex G. Go from G to the reflected line. And then I just need to continue that on the other side. Okay, we'll see if I made those lines long enough. Okay, so we have perpendicular lines with the reflected line and a line connecting to the vertex. Now what we're going to do is maybe find another way to measure this. So since I've got this rectangle I can work with, I can resize this and make it smaller so that it's the same size as, you know, I want that same length. So if you notice, my rectangle is going from F to the line of reflection. So without changing the size of it, I'm going to drop that down so that I can get that point right here, and that's going to be F prime. So you could probably just take a piece of paper and measure, like draw a tick mark to see how long that is, but just on this iPad, this is kind of what I have to work with. All right, so now I'm going to make this one smaller to match that length, and then I'm going to bring, oops, I got to make sure I don't change that when I move it. I've kept that size the same, and I'm going to have H prime over here. So what we're doing is we are finding F to the line of reflection is congruent to F prime to the line of reflection. H to the line of reflection is congruent to H prime to our line of reflection. And then we just need one more. We need point G. Whoa. All right, so point G, I'm just going to make my rectangle go from G to the line of reflection, and then I'm going to not change the shape of that and move it down here, line it up so I can just get G prime. Well, let me get rid of that. Okay, that took a minute to get rid of that rectangle. All right, now we're just going to connect our points. We have from H prime to G prime to F prime, and H prime to F prime. And that is our reflected triangle of FGH is reflected across our line of reflection to give us F prime, G prime, H prime.